Okay, good morning, everyone. Do you remember the portions that we had discussed in the last class? Different steps to draw the Louis structures. Anyone, please tell me. Meherin, can you tell me the steps?
First step is count the total number of valence electrons.
Yes.
Then second step is draw the skeletal structure. Then draw single bond and draw multiple bond.
Okay. Multiple bond or lone pairs. Okay. Lone pairs also there, right? And in the second step, when we draw the skeletal structure, which atom should be at the center? Emmeline? Yes.
Least electronegative atom.
Okay, least electronegative atom. Then we can practice more examples. Before that, Tom Sinton,
Yes, ma'am.
are you ready for the seminar?
Yes, ma'am.
Okay, then you can proceed. What's your topic?
Ionic radii.
Okay. All of you switch on your videos.
Can you see it, ma'am?
No. Did you share the screen?
Just a minute.
Okay, okay.
Give me 1 minute, ma'am.
Okay.
Something.
Okay.
So, good morning, everyone. Today I'm here to take a seminar on the topic ionic radius. Oh, once again, it's stuck, ma'am.
Then you can present it in the next class. No issues.
Okay, ma'am.
Okay. Yeah. Okay. Then now we can revise the portions from the first chapter onwards. Then you have to just note down the important points from each chapter. Okay. What about your revision? Have you completed? Have you started? All are smiling. Okay, so we can start from the first chapter. All of you, please switch on your videos. So here from the first chapter, the topics are included in the syllabus. Just 1 minute, children. Okay, that's the general introduction. Then the importance on scope of chemistry. Then from atomic and molecular masses. That means the properties of matter and their measurement. Then international system of units, mass and weight, volume, temperature, uncertainty in measurement, scientific notation, significant figures, dimension analysis, laws of chemical combinations, the Dalton's atomic theory. These all portions are not included in the syllabus. Okay, so from atomic mass and molecular mass onwards. First one, general introduction, then importance and scope of chemistry. Then the next portion is atomic mass and molecular mass. In this section, you have to learn the method to find out the molecular mass. There will be definitely one question to find out the molecular mass. Okay, what's the method to find out molecular mass? Anyone? How can we find out the molecular mass of the substance? Yes, unless, can you tell me? Molecular mass. Unless. Yes. How to find out the molecular mass?
Number of moles divided by.
Yes, just sum of the atomic masses of the element present in that molecule, right? If we are find out the molecular mass of NH3, how can we find out? We will sum of the atomic masses of atoms present in that molecule. In the case of nitrogen, it's 14, then plus hydrogen, it's 1. So 3 into 1. Here it is 14 plus 3, 17. It is the molecular mass of ammonia, right? So it's just the sum of the atomic masses of the elements present in that molecule. Okay. So to write down the molecular mass, you have to learn the atomic masses of the elements. That will not be given in the question. So the important atomic masses of the element should be learned. Hydrogen, oxygen, nitrogen, chlorine, sodium, sulfur. Okay, I think you already know the atomic masses of the elements, right? Then the next one, that's about mole concept and molar masses. What's the Avogadro number? Value of Avogadro number, Alentina?
6.022 into 10 raised to the
23. Who introduced this Avogadro number, Jewel?
Avogadro.
Yeah, Amedeo Avogadro. Children, please switch on your videos. Shreya, Tom, Alina, Lakshmi, all of you. Jees, Shabari, Navaneet, Anchana, Irene, Rahul, Abhinav, Samia. Okay. So from the small concept, you have to learn the method to find out the number of moles. Number of moles. Then the molecular mass of the each substance using this number of moles. That means if 2 moles are present and you have to find out the molecular mass of some substance, how can we find out? If 2 moles of water are, okay, if 2 water molecules are present there, find out the molecular mass. How can we find out? Molecular mass of 2 moles of water molecule. Tell me. 2 moles of H2O. What's the molecular mass of 2 moles of H2O? What's the molecular mass of H2O? Yes. Molecular mass of H2O. 18, right? 18 gram. That's for 1 mole, right? 1 mole. So for 2 mole, it will be 2 into 18, right? 2 into 18. Yes. Then percentage composition. What's the method to find out the percentage composition of the elements present in an molecule? Shabari, can you tell me?
Mass of the element by mass of the molecule into 100.
Yes, mass of the element by mass of the molecule into 100. So you should be learn this percentage composition. Sorry. We can just do one example. Yes. CO2. Find out the percentage composition of carbon in CO2. Percentage composition of carbon in CO2. So here the mass of this element carbon, that is 12. then divided by the total mass of carbon dioxide. That will be 44, right? Into 100. This is the percentage composition of carbon. 12 by 44 into 100. If in the case of oxygen, 2 oxygen atoms, right? 2 oxygen atoms. So 2 into 16 by 44 into 100. Okay, so this is the method of finding the percentage composition of elements in a molecule. There will be definitely one question from this part to find out the percentage composition of the elements in a molecule. Okay. So clear, children? Yes, okay. Then the next one, that is empirical formula and molecular formula. You have to learn to find out the, yeah, Niranjan?
Laws of chemical combinations are known to.
That's not included in the syllabus, laws of chemical combination.
Okay, ma'am.
But it's simple, right? You can learn this, laws of chemical combination. It's always needed for the chapters. Then empirical formula and molecular formula. The method of finding this empirical formula, and from this empirical formula, we can able to derive molecular formula. So you have to follow this method. Then the stoichiometry and stoichiometry calculations. This portion also included. That means to balance this equation, and we can represent this equation in the form of mole, molecules, volume, etc. So you can just go through the different methods of representation of a chemical equation. Okay, through moles, molecules, then volume, etc. So these are the portions from the first chapter that's included in the syllabus. I will repeat it once again. General introduction, importance and scope of chemistry, atomic and molecular masses, mole concept and molar mass, percentage composition, empirical and molecular formula, chemical reactions, stoichiometry and calculations based on stoichiometry. Okay, so in the last part, this reactions in solutions, mass percentage per or weight percent, then mole fraction, molarity, molality. Also, you can learn different methods of expressing the concentration. Mass percent, mole fraction, molarity, molality. Clear, children? Method of finding percentage composition, molecular mass, then the problems related to mole concept and molar masses. These are more important. This is clear? Shall I move to second chapter?
Yes.
Yes. So in the second chapter, the portions are from Bohr model and its limitations. Okay, Bohr model and its limitation. That means from 2.3 onwards. 2.3. Developments leading to Bohr's model of atom. The two major developments that leading to the formulation of Bohr's model, which are they? John, can you tell me? John Joes. Two developments that leading to the formulation of Bohr's model.
And the line spectra of hydrogen.
Yeah, then one more.
And the black body radiation.
Yeah, dual character. It includes black body radiation, photoelectric effect, everything. Okay. So these are the two developments that leading to Bohr's model of atom. Then first one about wave nature of electromagnetic radiation. In this portion, you have to learn which are the electromagnetic radiations and their correct order in the increasing order of wavelength or decreasing order of frequency. You have to learn it in the correct order itself. Starting with gamma ray, X-ray, etc. So can you tell me which are the different electromagnetic radiations? Anashwara, can you tell me in the correct order of wavelength?
Ma'am, gamma rays, X-rays, UV rays, visible ray, IR ray, then radio waves, and
One
and
more.
with,
Microwave, radio wave. Okay, that's the order. Then there are certain terms related to this electromagnetic radiation, that is frequency, wavelength, wave number. They are symbols and units. Okay, they are symbols and units. Then what about the value of velocity of light? Malavika, Vibin, can you tell me? Velocity of light. It's a constant value.
Ma'am, I don't remember.
Anyone? Aditya? Yes.
3.2.
3 into 10 raised to 8, right? 3 into 10 raised to 8 meter per second. That's the velocity of light. It's a constant value. Then what's the relation between velocity of light, then wavelength and frequency? Anyone?
Nu equal to C by lambda.
Yeah. Once again?
Nu equal to C by lambda.
Yeah, nu equal to Z by lambda. Then the next portion is particle nature of electromagnetic radiation. It includes the Planck's quantum theory, then black body radiation, then photoelectric effect. Okay, so these all phenomenon it can be explained using the particle nature of electromagnetic radiations. There are two types of nature for this light, wave nature and particle nature, right? This black body radiation and photoelectric effect, it can be explained by particle nature of electromagnetic radiation. And this wave nature of light, it can be explained using this wave theory of light, we can explain interference, diffraction, etc. So here you have to learn what is black body radiation, then how its result will affect the particle nature of light. Here, according to the change in its temperature, different sets of wavelength are emitted. Okay, that means at a particular temperature, a bundle of light is emitted. Then at another temperature, another bundle of light is emitted. So here it is considered as certain bundles, not as a continuous wave. That's why here it is considered as particle nature of electromagnetic radiation. So you have to learn this black body radiation. Then very important one, that is photoelectric effect. Photoelectric effect. What is photoelectric effect? Tell me. Anyone? Photoelectric effect. Devika, can you tell me? Devika?
Yes, ma'am. When a light, yes, ma'am. When light of certain wavelength falls on a metal surface such as rubidium or cesium, electrons are ejected from the metal surface.
Yes. Then what is threshold frequency? Anyone? Okay, I will call the name. Lakshmi. Lakshmi, yes. What is the threshold frequency?
Threshold frequency should be more than the frequency, then only the photoelectric effect can be
ejected, right? The minimum frequency that is required for this ejection to take place. Okay. Then you have to learn work function, threshold energy, then the different features and characteristics of this photoelectric effect. And who developed or who performed the experiment related to this photoelectric effect? What's the name of the scientist?
H. Hertz.
Yeah, H. Hertz. So this one is very important, photoelectric effect. Then the dual nature of electromagnetic radiation. It contains emission and absorption spectra and the line spectrum of hydrogen. This line spectrum of hydrogen, it's also important. There are different series there, right? What about the names of different series present in the atomic spectrum of hydrogen? Malavika, can you tell me?
Lyman, Balmer, Paschken, Fun.
Your voice is too low.
Lyman, Balmer,
Yeah.
Passion, bracket, Fun.
Fun. And you have to also learn from which level to which level this series will be generated. Here in the table 2.3, N1 and N2 is represented. N1 is considered as the ground state. Okay. So from which level to which level each series should be emitted. Okay. In the case of Lyman, it's to first energy level. And in the case of Balmer, second energy level, Passion, third energy level, like that. And which one sees in the visible region? Visible region. Among this different series, which one sees in the visible region? Anyone?
Balmer.
Yeah, it's Balmer. Then what's the value of Rydberg constant? Rydberg constant. Tom, can you tell me? Tom. Value of Rydberg constant. Yeah. It's 109,677 centimeter inverse, right? You can also convert it into the form of other units. Here it is represented in centimeter inverse. Okay. Then Bohr's model of hydrogen atom. The different postulates related to the Bohr's model for hydrogen atom. You can go through this. And main thing, that's the quantum numbers. Different quantum numbers. Before that, you have to learn the limitations of Bohr model, then applications of this Bohr's model of hydrogen atom. Then the Heisenberg's uncertainty principle. It's very important. Heisenberg's uncertainty principle and its mathematical equation. What is this Heisenberg's uncertainty principle? Ellen Joshi, can you tell me? Heisenberg's uncertainty principle. Ellen? Not there. Samia, can you tell me? Switch on your videos, children.
Ma'am,
Yeah.
it rules out the existence of definite paths.
Heisenberg's uncertainty principle. It is impossible to determine simultaneously both the velocity and position of the particle, or both the position and momentum of this particle. That's Heisenberg's uncertainty principle. Then what's the mathematical equation? Delta x into delta p greater than or equal to h by 4 pi. Both this statement of Heisenberg's uncertainty principle and mathematical equation, it's very important. Then what about the de Broglie wavelength equation? De Broglie wavelength equation. Pooja, can you tell me? Pooja. Yes. De Broglie wavelength.
And lambda is equal to h by p.
Okay, lambda equal to h by p or h by mv. Okay, fine. Then, yeah, what is Schrodinger equation? Schrodinger equation. Jewel, can you tell me? Yes. Okay, Renil, can you tell me? Schrodinger equation. Schrodinger equation. That is h psi equal to e psi. Okay, h psi is equal to e psi. Then we are moving to this quantum numbers. It's very, very important. Different quantum numbers, their symbols, and what's their significance. There are 4 types of quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Then principal quantum number can be represented as small letter n, azimuthal quantum number or orbital angular quantum number L. Then the magnetic orbital quantum number M, ML. Then the last one is spin quantum number, that is S. And what's the significance of principal quantum number? Tom Sinton, what all information provided by this principal quantum number?
It tells us about the size and energy
size and energy. Then shell also, right? Yes.
Yes, ma'am.
So it will give information about energy, size, shell. Then Mehreen, what about azimuthal quantum number?
It gives the three-dimensional shape of the orbital.
Yeah, three-dimensional shape of the orbital. Emmeline, what about magnetic orbital quantum number?
Arrangement of orbital.
Yeah, arrangement or orientation of orbitals. Then the last one, spin quantum number. Niranjan, can you tell me what all information provided by spin quantum number? Niranjan?
Yeah, ma'am. About
Yeah.
electron spin.
Yeah, about electron spin, either clockwise or anti-clockwise direction. Only two values there, plus half and minus half. Along with this, you can also learn the values. What will be the value of principal quantum number? How it is related to azimuthal quantum number? You know that L values are from n minus 1, 0 to n minus 1. Then in the case of magnetic orbital quantum number, negative L to positive L, including 0. These are the values for magnetic orbital quantum number. And in the spin quantum number, either plus half or minus half. So this portion is very important. Then the shapes of atomic orbitals. What will be the shape of s orbital? Anyone? S orbital. Spherical shape. P orbital. P orbital. Dumbbell shape. Then in the case of d orbital, it's also a form of dumbbell shape, but double dumbbells are there, right? Yes. Then, yes, different rules for filling the electrons in orbitals. Which are the three important principles? Hund's rule of maximum multiplicity, starting with Bohr principle, right? Bohr principle, then Pauli's exclusion principle, Hund's rule of maximum multiplicity. In Pauli's exclusion principle, it's about the energy of different orbitals. 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay. Then the second one, Pauli's exclusion principle, no two electrons in an atom can have the same set of 4 quantum numbers. Then the last one is Hund's rule of maximum multiplicity. That's related to the pairing of electrons in the orbitals. Only after the one electron is singly occupied electron is there in the orbital, then it follows the another electron. Only after the occupation of single electron in the orbitals, then the another electron will be occupied in the same orbital. That's Hund's rule of maximum multiplicity. Then the electronic configuration of atoms, both in orbital form and in the subshell configuration. Both forms are important. So these three rules, they are very important. Okay, Pauli's exclusion, Hund's rule of maximum multiplicity, then Bohr principle. And the last one, you have to learn the electronic configuration of the copper and chromium and the reason for their electronic configuration. It is completely filled orbital and half filled orbital related to stability. Okay, it's very important. So these are the important points related to this chapter. Then one more thing, the method of finding the nodes. Okay, in the case of total number of nodes, it is n minus 1. And the angular nodes, it is L. And radial nodes, n minus L minus 1. These are the three equations. N minus 1, total number of nodes, L, angular nodes, n minus L minus 1, radial nodes. If it is 3D, what will be the total number of nodes? N minus 1, right? So 3 minus 1, that is equal to 2. And the angular nodes, here it is D. So here the values of this subshells, it is S, P, D, F. So here the value of L, that is equal to 2. Right? Then n minus L minus 1. 3 minus 2 minus 1. That is equal to? Tell me. That is equal to?
0.
Yeah. 0. That's it. So you have to learn this equation to find out the total number of nodes, angular nodes, radial nodes. Then we are moving to the third chapter. Classification of elements and periodicity in properties. Classification of elements and periodicity in properties. In this chapter, the portions are modern periodic law and the present form of periodic table. Then periodic trends in properties of elements includes atomic radii, ionic radii, inert gas radii, ionization enthalpy, electron gain enthalpy, electronegativity, valency. Then the nomenclature of elements with atomic number greater than 100. So here the portion starts from 3.3. 3.3. Modern periodic law and the present form of periodic table. So here you have to learn the modern periodic law. It's very important. What is modern periodic law? Abhinav, can you tell me modern periodic law? Abhinav. Sanjana.
Yes, ma'am.
Can you tell me modern periodic law?
The physical and chemical properties are periodic function of the atomic number.
Okay, atomic number. Okay, here they are the periodic functions of atomic number, not atomic masses. Okay, then you should learn the nomenclature of elements greater than 100. There will be one question from that part. Nomenclature of elements greater than 100. Then the electronic configuration in terms of periods, then group wise configuration. Yes, then different types of blocks and their properties. It's also important. S, P, D, F. And this 4 blocks, in the case of D block, you know that there are different types of properties. Variable oxidation state, then colored compounds, about their magnetic property, then they will act as catalyst. So you have to learn the different blocks and their properties. In the case of S block elements, alkali metals and alkaline earth metals, then P block elements from group 13 to 18, then transition metals from 3 to 12, then F block elements, that is the inner transition elements. Then the different names, that means alkali metals, alkaline earth metals for first and second group, then 17th group halogens, 18th group noble gases, 16th group chalcogens, then S block and P block together known as representative elements, then 3 to 12 transition metals, lanthanoids and actinoids, inner transition metals. Okay. Yes. Then the metals, non-metals and metalloids. Always group 1 and 2 belongs to metals. Then moving towards the right side of the periodic table, non-metals. And the metalloids are in a zigzag portion in the P block element itself between metals and non-metals. Examples for metals, non-metals, metalloids. Then the periodic trends in the properties of elements. This portion is very important. All the periodic properties, physical properties are important. First one, atomic radius. So you have to learn the physical property and their trend followed in each case in period and group. Okay. What about the periodic trend followed by atomic radius in a period? John Joes, can you tell me in a period?
And the atomic radius decreases.
Yes, atomic radius decreases in a period, atomic radius increases in a group. You have to learn the reason also. Then there are different types of radius, covalent radius, metallic radius, etc. Then ionic radius. In the case of ionic radius, 1 minute. Yes, ionic radius, there is cation and anion. Cation is positively charged ion, anion is negatively charged ion. Then the importance, that means the size of the anion and cation compared to their parent atom and their reason. It's very important. Okay, size of cation and anion with its parent atom, this is very important. Then isoelectronic species, it's also important. Isoelectronic species. What is this isoelectronic species? Anyone? Isoelectronic species. same atoms or ions with same number of electrons. So you have to identify the total number of electrons. We can do one example. Just wait. Here we are considering neon and Na plus. Okay. So the configuration of neon, it is 1s2, 2s2, 2p6, right? And what about Na plus ion? Na plus means they will donate one electron, right? Then their representation also 1s2, 2s2, 2p6. So these two are considered as isoelectronic species. So there will be one question to identify isoelectronic species. So you have to write the electronic configuration and count the total number of electrons. If it is same number of electrons present, you can identify both the atoms or ions as isoelectronic species. And in the case of cation and anion, which has larger radii compared to parent atom, cation or anion? Devika?
Ma'am, anion.
Anion, right? Then you have to also learn the reason. The next one is ionization enthalpy. You have to learn the definition of ionization enthalpy and the periodic trend followed by ionization enthalpy in a group and period. It's important. Including the shielding effect, then effective nuclear charge, penetration effect. You have to learn all this properties also. Then next one is electron gain enthalpy. Learn the definition of electron gain enthalpy, periodic trend followed by electron gain enthalpy in a period and group. That's also important. And which is the most electronegative element in the periodic table? Highest electronegative element in the periodic table. Malavika?
Fluorine.
Yeah, it's fluorine. There are certain exceptions in the periodic trend in period and group, right? In the case of oxygen, fluorine, then sulfur, chlorine, etc. So you have to learn the reason for that. Then the electronegativity, that is highest electronegative element, then the periodic trend followed by electronegativity in group and period. Then in the last section, you have to learn the periodicity of valence or oxidation states. And also learn the anomalous properties of second period elements and their reasons. So these are the main important points for your coming exam. Okay. Just 1 minute. Yes, you can also learn the maximum number of electrons accommodated in each orbital. Okay, the total number of electrons present in each shell. Okay, so these are the important points related to three chapters. This is clear, children. If you have any doubt in any portion, you can ask me. Okay. Now it's time to wind up, right? So let me take your attendance. Just wait. Okay, then we can discuss the UV structures and its examples in the next class. So all of you prepare well for the exam. All the best for your exam. Okay. It's on 6th, right? 6th, isn't it? Chemistry examination on 6th. Monday. Yes. Okay. Okay, children. Then thank you all. See you in the next class. Bye.
Thank you, ma'am.
Thank you.